Okay, so I'm re-recording this section here, the diagnostic quality, because it got lost on the other recording. So we're going to go over these slides. Actually, no, sorry, I'm going to fast forward here till we get to analysis of error and artifacts. So this was dealing with the traditional films and the errors that can be seen. So recognizing technique errors, recognizing the correct processing errors, and analyzing FMX for errors and necessary retakes, although we're not really going to discuss that too much because we've talked about it a lot. And then observing things like penumbra, magnification, and distortion through the shadow casting activity. Well, we already did that. So some of these objectives aren't going to be covered in these slides that I'm just going to re-record. So technique errors and processing errors, we know our placement error is how we have in error placed the sensor in the wrong position. So it's not covering the teeth that we want it to, or the teeth that we want are not in a proper place on the sensor. So like not centering it or not showing the distal of the canine. Horizontal angulation, closing contacts, vertical angulation, foreshortening, elongation, and then beam centering error. The BID is not covering all of the sensor, so we get the white mark. So here's an example of movement. You can see how there's just sort of a little bit of an overall blurry look, and the penumbra is more defined or more specific. It's more obvious on this film. This is what happens when we have the digital sensor backwards, although a lot of times you just won't get anything. Nothing will show up. And I don't know why this shows up sometimes. Most of the time it doesn't. This is leaving the lead foil. You can see the lead foil because the traditional film is placed backwards in the holder. So that's what this kind of tire tracks are. It's the lead foil. A dot artifact can cause distortion when located in the apical region. So on a traditional film, you have the little raised dot, and it also makes more of a radiolucent area on the film. And so if you don't put it toward the occlusal surface, then it can be confusing and you might think it's like a periapical lesion. So the rule of thumb is always the dot in the slot, and that's when referring to traditional films. This one is a dimensional distortion. There's some bending, severe bending of the film. And so the picture got really distorted. You can also see some bend mark right here. And again, another bend mark. You can see how there's dimensional distortion there. Fingernail marks from rounding and pushing on the film to kind of round it out. Another bend mark down here in the corner. A double image. They took a molar shot and a lower anterior shot on the same film, so they exposed it twice. This is a cord. Some of you have already seen this because your cord got in the way of your digital image. This won't happen with a traditional film. This only happens with digital film. If there's a blank film or no image, then a couple things happen. You forgot to align your BID, or you forgot to turn the machine on, or perhaps your sensor is backwards. So those are reasons why you just get a blank film. We talked about this in class. This is the denture that's left in, the kind of floating ghost teeth. And then here's a couple images of the traditional developers. So we have the AT2000. There was another one that started with a P. I can't remember the name of it, but this one is the one that we used to the one I would see the most when we were using mostly traditional film instead of digital, the AT2000. So here's some processing errors. So if a film is overall darker or there's higher density to the film, some of the possible causes can be excess developing time. So it spent too much time in the developer. The developer's temperature is too high. If your thermometer is not measuring the temperatures right, then that's can lead to high or low temperature. And then overactive developer solution. So it's not measured outright or it's too strong. A low density film or an overall light film, the causes of that can be inadequate developing, low developer temperature, inaccurate thermometer again, depleted developer. So if it's a light film, your chemicals are exhausted, your chemicals are depleted. Processing errors for black artifacts. So when you see black, you can think of the developer. So there's developing spots on here that have made some darker areas. This is some saliva contamination that makes very dark. And then this is the fixer cutoff. So, and the fixer cutoff and the developer cutoff, you have to really think about what actually happened in order to sort of remember what it is. So if it cut off the fixer, that means that part of the film never got any fixer on it. It only got developed. So it's overdeveloped, and so it's black. Some other black artifacts are overlapped film, light leak. See how it's a little diffuse through there? That's how you can tell the difference between a fixer cutoff and a light leak. One is a sharp line, the other is more diffuse. Fingerprints all over the film here. Now with white artifacts, we have fixer chemical spots, air bubbles, and a developer cutoff. So it didn't get developed on this area, it only got fixed. And so that's why it's white. If you see brown or stain, you can know that those chemicals are either exhausted or weak, or it could be fixer chemicals, insufficient fix time, or insufficient rinsing. So exhausted chemicals and insufficient rinsing are probably the two main ones. But if it went through the fixer too quick, so those weird colors are not fully fixed. So they went through the developer, but they didn't get enough fixing time to like make it look like how it's supposed to. And then it just went through water, but it left this weird look on the film. Static electricity, moisture contamination, these kind of dark spots. Film fog, outdated film, improper storage, it maybe got exposed to light, higher developing solution temps, poor storage of the films. Those are all options or causes that could potentially happen. This is the emulsion got torn. You can see how it leads some kind of like white areas. If you held that up to light, you would see through it. If the emulsion gets scratched off, that means that all the chemicals that are going to help make or create an image are gone. And so if you scratch them off, once you put it through the developer, it's just going to look clear. So that's the coating has been scratched. Double image here. This looks like a light leak because it's kind of diffuse. Tips to feeding the film: should be fed into the machine slowly and straight. If the film is bent, the unbent side should be inserted first, so it's less likely to like catch on the rollers. Don't feed damp films into the processor. Films should not be fed in too quickly because you don't want them to overlap. And that's it. That's a super quick video, like 9 minutes. All right, have a great day, you guys.